this session is devoted to chemical education, and I will try to discuss a little bit the relation between epistemology and chemical education, taking as an example the case of the notion of chemical bonding. So much has been written on chemical bonding, both as regards to its modeling description and to its nature, whatever this word means. So in this talk, I will focus on some epistemological issues related to the bonding notion that are relevant to chemical education. Despite its foundational character for chemistry, the notion of chemical bond raises several problems on the educational side. Several investigations show that students experience serious obstacles in understanding this notion, and they often prove unable to use it effectively. So these are some of the educational problems related to how students acknowledge the bonding notion. They often mix up different modeling approach. They have a dichotomous view of intra and intermolecular interaction, and the role of electrons in bonding is largely misunderstood. Taber was extensively worked on misconception concerning the chemical bond, as written about what he calls the molecular frame and the history conjecture. That results in the belief that bonds are always directional and all substances are made of molecules. Then there's not enough emphasis on the energetic aspects of bonding, and also the immaterial nature of bonds is largely misunderstood. So several surveys show that these misconceptions are recurrent in distinct teaching and cultural environments. And these are likely fostered by inappropriate didactic transposition, which in turn may be related with a lack of epistemological reflection of many teachers. So it seems to me that the notion of chemical bonding is an optimal ground for discussing the two-way relation between epistemology and chemical education. I call it a two-way relation, as epistemology may inform chemical education by highlighting conceptual notes, inconsistencies, and on the other side, chemical education raises questions to which epistemology is called upon to answer. So in my reflection on the notion of bonding, I've identified 5 distinct aspects of bonding that deserve to be discussed under an epistemological perspective and should be taken into account in the teaching practice. These are modeling, that is to say, the relationship between models and reality, the relational nature of bonding, which is related with the complex perspective on bonding and is somehow related to what Jean-Pierre was discussing earlier. The terminology, the terminological aspect, that has to is also related with this dichotomous view of interatomic interactions, the energetic aspects and semiotic aspects, that is to say, the representation of bonds. Now, given the time constraints, I will focus just on the first aspect. And I also wish to say that these reflections have been inspired by a PhD project on the didactic of chemical bonding that's been carried out by Federica Branchini under my supervision. So what I'm going to say are kind of preliminary reflections, but I wish to share these reflections with you, even if they're somehow incomplete, because I hope to get suggestions and critiques that may help Federica and myself to progress in this work. The nature of bonding. So the nature of the chemical bond is the title of one of the most renowned texts on the subject. Nevertheless, I must say that I share the feelings of Vemulapalli as regards to talking about the true nature of bonding. I prefer talking about possible definitions of bonding and reliable descriptions of this phenomenon through the design of effective models leaving aside any pretense of truth. At the same time, I believe in the need of discussing foundational scientific notions as, according to the Ray and Scheich, they risk to be taken as an evidence with the result that no further exploration seems necessary. The nature of bonding is difficult to grasp, and sometimes one gets the impression that chemists have given up on discussing it further. The same is true for the role of bonding. For example, the rise of supramolecular chemistry calls for an epistemic reflection on the chemical role of intermolecular bonds, which in chemical education are too often related exclusively to physical changes. In addition, these are usually treated separately from chemical bonds, a choice that, according to many scholars, has several educational drawbacks. The notion of bonding, what for? So this question seems so obvious to appear unnecessary, but here I wish to remind that my perspective is an educational perspective. I'm interested in how the bonding phenomenon is taught at school. Now, experts in chemical education always recommend that whenever a new notion is introduced, teachers should clarify where the need for that notion comes from. This is rarely done with the bonding notion. The usefulness of the concept of bonding is rarely discussed in the classroom. It's rather taken as a self-evidence. This notion is directly introduced to students through the descriptive models of bonding. So students may end up asking questions like, why so many models, or which is the true definition of chemical bond? Now, these quotations remind us what the notion of bonding is for. That is to say, what is the meaning of the chemical bond to the chemistry discipline? Bonding is rooted in the idea of chemical affinity. It helps explaining both chemical and physical phenomena, and it's also useful in the classification of transformations of matter. Chemical changes are characterized by the breaking and making of chemical bonds, as Robin Hendry reminds us. Physical changes are characterized by the breaking and making of intermolecular interactions, which are bonds as well. Thomson, in his 1914 paper, stressed the fact that chemical and physical phenomena are explained in terms of the mutual action between atoms. This reflection is still valid. Nowadays, if Zhao and co-workers relate the notion of bonding and bonding mechanism to chemical reactivity and to the plurality of substances and the plurality of relations between substances. But what is this thing called bond? Franklin introduced the term bond in 1866 by stressing the fact that the term is intended to indicate something immaterial. In his 1996 paper, Sutcliffe remarks Franklin's wish to avoid any speculation as to the nature of the tie which enables an element to attach itself to one or more atoms of other elements. And in fact, chemists were able to use the notion of bond even in the absence of a formal description of this phenomenon. In his book on the chemical bond, Pauling underlines that the notion of bonding is related with the notion of stability. A chemical bond implies that the forces acting between two or more atoms are such as to lead to the formation of an aggregate with sufficient stability to allow chemists to consider it as an independent chemical species. Actually, these definitions mention independent molecular species, although in the subsequent lines, Pauling remarks that such definition is valid also for non-molecular substances, such as ionic substances. So we might say that bonding is part of the theoretical interpretation of the notion of chemical stability. So based on Pauling, bonds are the results of the action of interatomic forces, and they are related with stability of interatomic aggregates and with the notion of molecule. But Pauling also states that bonds are theoretical constructs, idealizations. Now, a lot has been written about the real or conventional character of bonds. Both Gillespie and Coulson seem to share Pauling's view on the ideal character of bonds, and they push it even further. Bonding are idealization, figments of our own imagination, says Coulson. Thus they have no physical reality, says Gillespie. I quote, a chemical bond is not a real thing. It does not exist. No one has ever seen it, say Coulson. So the question is, what level of reality do bonds belong to? Del Re has a different position. In his 1996 paper, he criticizes the reduction of the notion of bond to a mere idea, just as he criticizes the reduction of the notion of molecule to a mere idea. His critics is based on experimental evidence. Bonding is associated with measurable properties. And this is also Politzer's position, who remarks that energy, just as bonds, has no direct physical reality, yet it can be measured. We can measure bond length, bond angles, dipole moments, elastic force constants. All these are taken as a sign of the reality of bonds. And there goes so far as to say that the chemical bond is a bearer of transferable properties. I quote, the hypothesis that bonds exist allowed explaining and predicting the main features of molecule with sufficient precision along 130 years of development of organic and coordination chemistry. According to the Re, this proves that bonds exist and are essential to chemistry as they are part of the cognitive program of chemistry. So the notion of chemical bond belongs to the conceptual territory of chemistry. The problem of the reality of bonds is also commented by Sutcliffe, who says that even if most chemists would admit that bonds are figments of our imagination, nonetheless, they would claim their existence. And I quote again the Re, who remarks that the level of reality of bond is not the same as first-class entities, that is to say, entities existing per se. The experimental observability of a number of properties that we associate with bonds allows stating that the idea of bonding has a clear correspondence in the physical world, albeit it's being immaterial. Clearly, this debate reflects the contrast between realist and anti-realist, with all the intermediate shades between these two positions. From the educational viewpoint, the mention to experimental observability is relevant as it reflects on the problem of acknowledging the relationship between models and the real world in correct terms. Models are theoretical constructs with an explicative and interpretive function. They allow interpreting experimental findings, and their existence makes sense only in the light of such experimental findings. Models are rooted in reality in that they aim at giving logical explanations to experimental evidence.
Sorry, Elena, you have
Yes?
5 minutes left.
Yeah, okay. More precisely, Dere compares the notion of chemical bond to the notion of structure. Both of them are principal, that is to say, second-class entities, entities that do not exist per se because they need a carrier. And that's why, according to Dere, second-class entities have to be defined by means of an analogy. In a different perspective, not in contrast with the previous one, Zhao leads back bonding to its energetic aspects. Bonding is an energetic phenomenon whose descriptors have a specific chemical meaning. Now, as I mentioned bonding models, I find relevant examining what is probably the most renowned definition of chemical bond, which was given by Lewis, and Eric recalled it in his talk. When the electron pair is situated between two atoms, and thus may be said to belong jointly to the two atoms, it is the agent of chemical union. Whether we are dealing with organic or inorganic compounds, the chemical bond is always such a pair of electrons. I find this statement interesting because it seems to me that it mixes a model description of bonding, the chemical bond is a pair of electrons situated between two atoms, and a philosophical definition, the electron pair as the agent of chemical union. Here, Lewis combines the needs to express the meaning of bonding with another need, the need for an operational definition, applicable and well recognizable. In other words, in Lewis' statement, concept and model coexist, and they even overlap to some extent. And interestingly, Lewis was well aware of the limitations of this definition. Already in the Faraday meeting in 1923, he knew and mentioned the fact that the existence of stable species like H2+ challenged the idea of the bond as a shared electron pair. In fact, in his 1933 paper, he explicitly stated that the bond need not always to be a pair. This does not affect the idea of electrons as the agent of chemical union, but the model shows its limits. The philosophical definition remains valid. So just to go towards the conclusion, going back to chemical education, what does epistemology teach us about the notion of chemical bond? In which way it informs chemical education on this subject, and what is relevant to be taught in school on this subject? When I say meaning first, I intend to stress that the concept of bonding and its interpretive models belong to distinct conceptual levels. The concept lies upstream from its descriptive models. The notion of bond, understood as interatomic interaction, spans the history of chemistry from Dalton on because it is the expression of a philosophical need, the need to give a face to a relationship between atoms that arises in the context of the chemical discipline. Conversely, bonding models are the operational translation of that idea. A bonding model satisfies the practical scientific need, the need of characterizing the bonding concept and making it operational, for example, by constructing explanatory schemes that allow explaining and predicting the experimental behavior of substances. So, as previously remarked by several authors, the idea of bonding is also related with the notion of stability and helps justify the huge variety of substances with a wide range of physicochemical properties. All this has to do with the meaning of the bonding notion. As for its relationship with models, I like quoting Tilden, who reminds us that chemists have talked of bonds for years before developing consistent bonding theories and models. Bonding is a notion that guides chemical reasoning independently from its descriptive models. Along the historical path of chemistry, the bonding notion has been declined in many different ways based on the level of chemical knowledge of each historical period. The non-coincidence of the notion and its model is witnessed by the fact that distinct bonding models and theories coexist and share the same reference idea, the idea of bonding. Robin Henry reminds us that, I quote, the theoretical role of bonds within structural formulas predated both the discovery of the electron and the advent of quantum mechanics. Hence, it ought not to incorporate too closely the particular conceptions of the material basis of the bond. A relevant consequence of the existence of several models for a same concept is that each model implies its own definition of chemical bond. So different definitions of chemical bond may coexist without conflict. Just to conclude, I wish to mention the fact that the difficulty to grasp the nature of the chemical bond probably derived from its linear relationship, regulated by energetic factors, and this relationship has a deep chemical meaning that justifies the distinction between chemical bond and other kinds of bonds, namely intermolecular interactions. And in fact, chemistry needs to differentiate between internal relationships to molecular entities and relationships between molecular entities. But the question remains, what level of reality can we assign to a relationship? The ontology of relations is problematic, and I believe that the complexity paradigm may possibly orient towards a further understanding of the bonding notion. So, and I really conclude, I would like to say that in general, the teaching practice is too much focused on modeling and too less on meanings. The distinction between concept and model is rarely made, and this generates problems because The explanatory needs that the concept of bond is called to satisfy are not clarified to school students. The overlap between concept and models makes the use of different bonding models difficult to understand, because students may wonder what is the authentic model, the authentic definition of bond. Only the distinction between concept and model makes the evolution of the bond models and the consequent modification of the definition of bond in the passage from one model to another understandable. And the link between reality and its descriptive and interpretive models is not spelled out correctly, with the result that students are induced to confuse the empirical and the interpretive level. And I have concluded. Thank you. Thank you so much.
Okay, thank you, Elena. We have 3 questions. The first one is from Sheriff Mata.
Okay. Yes.
Sheriff, are you there? Yeah.
Yeah, I'm sorry, I was turning off the other computer. By the way, Elena, I know what my family name means in Italian. So anyway. So thank you very much for a beautiful talk. And I agree with you 100%. You know, Richard Bader used to say, I don't know what is chemical bonding, but I know what is, I don't know what is a chemical bond, but I know what is a bond path. And he used to emphasize, and I agree with him with some reservation here, that it is better to talk about chemical bonding, as you emphasize in one of your last slides. It is a relationship. It is not a thing. And educationally, when you tell the students that there is, you look at the language, there is a bond between this carbon and this oxygen.
Yeah.
You draw a stick, a solid thing, you know, and it provides the wrong psychology, you know, to the student. It's the wrong message that you're transmitting. It is not a thing. It's a verb. So Bader used always in his latter in the later part of his career, he used to use the word bonding, chemical bonding. Always, he refused to use the word chemical bond. He used bond path, but not bond. However, the little reservation I have is that in other languages that might provide some problem, because in French, la liaison chimique, how do you translate it into a verb? Maybe Pierre can help us. Or in Spanish, el enlace, or, you know, so it is not translatable easily in verbs, right?
I agree. Yeah.
Yeah, thank you. Thank you very much.
Thank you for your comments. Indeed, there's a terminological problem, and that's made even more complex by the differences in languages.
So you wouldn't, so would se lier, il se lie work, Sharif? Is he still there?
Pardon me, I didn't quite
would,
get it.
Would the verb, you know, like se lier, il se lie, they bond with each other, work?
Se lie, oui, peut-être, c'est possible, oui. Je sais pas, Jean-Pierre Lorette can
I see what you mean, Magina. Okay.
Okay.
Yeah, anyway, I think that the main point is to focus on the fact, on the process of bonding and not on bond as a thing, as Sharif was saying.
Okay, thank you. The second question is from Jesus.
Okay, can you hear me?
Yes.
Yes, perfect.
Okay, well, Elena, thanks for the interesting talk. I have only a clarificatory question.
Yeah.
It seems to me that you say that the bond, chemical bond, is a first-class entity, but then you say that no.
I just reported a position by the RE. I wasn't saying that that's my position. I just wanted to show different positions in the that I found in the literature, and the RE says that.
Okay, I see. But then for you, the chemical bond is a kind of relation?
chemical bonding is, for me, is a relation. Yeah, indeed. Indeed.
Okay, okay. Okay, thank you.
You're welcome.
Okay, and the last questions and comment is from Farsad.
Hi, Elena. Thank
Hi.
you for the presentation.
Thanks.
I was wondering if you were going to try, or you may consider trying applying that historical comment one of your quotations referred to, namely the concept of bond guided the research long before a definite concept existed. It guided the research toward different models. And if you want to, if you've said that there's not enough emphasis on meaning,
Yeah.
then is it practical? It's been a long time since I taught chemistry, so I don't remember. But is it practical to give students the emphasis on the concept of bonding as relation, and then get them to problem solve which models work better for which situations, and then sort of like introduce those things in process with specific substances or reactions, rather than favoring one model because it was the first one, or something like that. I was just wondering if you tried that, or if that's the way you already do it, or.
Actually, this is something that Federica, that I mentioned earlier, and I are trying to do, because Federica has designed a teaching sequence on the notion of bonding. So it's both on chemical bonding and intermolecular interactions. And the approach that we have tried to apply to this didactic transposition is exactly what you say. So work on the notion of bonding, on the meaning of the notion of bonding, and then taking inspiration from experimental evidence for introducing different models and explaining why those models are apt to interpret specific situations. And this is a different approach as the usual approach that you find in textbooks. And I mean, I think that this is especially important for school students, because at the university level, you have already you are already introduced to some extent to this kind of problems. But for school students, this is absolutely, it's absolutely important in my view to insist more on the meaning than on modeling. I think that this contributes to give even a more realistic view of what chemistry is.
Thank you. Yes.
Okay.
Thanks.
We started a little later, so I apologize to Bruno. And there is the last question from Eric.
Yeah, just a quick point and a suggestion. And this comes back to the excellent point that Sharif made about bonding as opposed to bond. I like to do this when I go from teaching classical bonding a la Lewis, which is about pairs of electrons, and then I move to molecular orbital theory, and now I say there are no bonds, there are bonding orbitals and there are anti-bonding orbitals, right? And another way of saying the same thing. And I suspect that that could be done in Spanish, Italian, French, and anything else I care to mention.
Okay.
Right?
I see.
Bonding and anti-bonding.
Okay. Yeah. That's a good suggestion.
Advantage of going to a quantum theory of bonding rather than staying classical, because it makes the concept much more abstract. Well, in a way, it's a disadvantage because the student wants to know what is a bond, but too bad they can't ask that question.
Well, I think that this approach can apply to university students. I'm not sure that this will apply to school students, because I belong to the school of thought that thinks that quantum quantum physics has to be avoided at school when you talk of bonding. But we are probably not we are probably on very different positions, Eric.
Okay, thank you very much, Elena.
Thanks, everybody.